Thank you. I hope you can see my slides.
Yes, we can.
Okay. So again, my name is Heliodor Macko. I'm from Slovakia, and I'm from the company which is manufacturing the controls for smart lighting for smart cities and buildings. And I will be talking to a little bit about how it works and where it makes sense. So actually, for me, it was quite a revelation to find out that almost 1/5 of global energy consumption goes for lighting. So that's why if you take a flight in the night, you see something like this from the window, if your flight is not grounded because of Corona. And the point is that most of this energy is wasted because when we implement smart lighting, we typically save 40% of the energy. Of course, the smart lighting is a technology that does not manufacture the energy. We are not beating the physics. The whole idea is that we should have lighting only in places where it is needed and in times when it is needed and in the intensities that are really needed. So anyway, what smart lighting is? It's pretty simple, honestly. First of all, we have to control each light individually. Because typically on one electric line, we have many luminaires, and if it's 2 a.m. in the morning, we don't need to have a full intensity, but for example, on pedestrian crossings or on road crossings, we still want to have more light for the sake of safety than in the other places. So it is necessary to control the intensity of each light individually. Second, smart lighting is providing remote diagnostics so that the people who are responsible for lighting are aware of any issues, any problems with broken light, and they are able to fix it before somebody complains or an accident happens. That's what we believe is smart and what we believe should be a standard everywhere. On top of that, of course, we are optimizing the lighting intensity throughout the year. The lighting conditions are not the same throughout the year. We are obviously managing and providing all the data about the consumption and the quality of the grid. And as you might have heard already many times, smart lighting is a great backbone for additional sensors and other Internet of Things devices that can be that can actually transmit the data or provide a last mile connection for all of these devices. Well, smart lighting is not exactly something new. It is here with us for many years. This is not some idea that would blow our minds to dim the light when we don't need it, honestly. But throughout the time, there have been many solutions and many approaches to this area. So first of all, the solutions were to basically put a SIM card and GSM module into each lamp. This works. This is fine. The only problem is that it is relatively expensive, and you have to pay for the communication and for the equipment. So in this particular case, most of the money that you save on energy, you are actually spending on the communication. So in the end, it is not so good for the city. Another approach is to use the radio mesh networks. This means that we do not have a SIM card in each lamp, but lamp number 1 transmits to lamp number 2, that passes the message over to lamp number 3, etc., etc. And then lamp number 100 is eventually receiving the command or the message and replies. And this is the way how all the communication works. This is also pretty advanced technology and provides a lot of good things. For example, the network is self-healing. So if there is an obstacle, the network tries to find another path to transmit the control signal between the lamps. However, in the cities, the typical situation is when we have long roads and the roads are linear. So in case we have a new building or we have a new tree or something which gets in the way, we get a problem. And in this case, we do not get a problem with one single light, but typically with a whole group of lights. And as the cities tend to change over time, the companies who are building this kind of networks, they are also building a business on maintenance of this network, because every now and then you need to resolve such issues with lost connectivity or changes in the landscape of the city. We at SEAK have chosen different paths. We are using existing power lines to transmit the control signals. So we do not need any additional control cables, and we do not need any antennas, and we do not need to rely on a radio signal that can be hacked. Basically, we use the same wire which is used to deliver the energy to the lamps, also for the communication. Especially because of this, we have a patented low-frequency power line communication that was designed for lighting. And this mechanism allows us to communicate with lamps in the distance of 5 kilometers, and from the communication point, and the communication speed is very low and very stable. So this is exactly what Internet of Things is. What you get, obviously, you get a cloud app that allows you to manage all the lighting and to define the groups of lamps. A typical use case is that the city defines different groups of industrial areas and residential areas and parks and pedestrian crossings and main square, etc., etc. And then for each of these groups of lights, they manage different lighting scheme. Of course, the lighting and dimming can be dynamic. So we can have additional sensors, including motion sensors. Typical example could be a municipal park. The park will get to full lighting after sunset, and if the park is closed at 10 p.m., then let's say 10:30, we are switching the lighting mode into motion sensor mode so that the whole light goes to 20% intensity and goes to 100% only in the areas where there is a motion, because for security reasons, we don't expect any movement in the closed park. But if there is something happening, it is great that that we have immediately light. And this not only improves the security, it actually saves 80% of energy throughout most of the night. So this is also economic grounds. And of course, you get all the reports about the potential problems and savings and consumption and everything. However, we have recently, a few years back, extended this approach to provide also EV charging from the lighting poles. The idea about this is actually quite simple. In many cases, we are changing the lighting from old sodium yellowish street lights to LEDs, and that makes sense on its own. Of course, when we are doing that, it makes sense to change this also immediately to smart LEDs so that we can also control the intensity and provide all the functions that I mentioned. However, the electrical wiring, which is already available and which has been built many years ago, was calculated for old lights. So the capacity of the wiring is much, much bigger than modern smart LED lamps actually require. So we decided that we create a system that allows us to make use of this capacity and to provide the electric car chargers at a very reasonable cost, because in this case we do not need to dig through the city. We are simply using the cables, the electric cables that are there already. Of course, you can use this by building a brand new lamp poles with everything integrated, like you see here on the right. Or it is also possible to retrofit old lamps by putting a wall box on top of it, and we can use the capacity in the same manner to provide for electric cars. How it works? Well, obviously during the daytime, the lights are off, so we have all the electrical capacity for the cars. The technology communicates with the cars and provides a load balancing function so that we fairly distribute the energy available between the cars which are parked on the street. Not every car has the same capabilities of charging and also needs of the charging. If the car is full, then we are disconnecting the car and we are providing the capacity to other cars which are available. So in this particular example, the total capacity of the line is 20 kilowatt. So during the daytime, all 20 kilowatt is available for the cars, And during the night, if the lighting intensity is at 100%, we need 10 kilowatt for the lights and 10 kilowatt we can give to the cars. Of course, after midnight, for example, if the lighting is dimmed, then we are able to provide more capacity to the electric cars. The whole idea about this is to allow people who are living in the street and they do not have their own driveway or garage to actually buy electric car, because you do not really want to have electric car and not have possibility to charge it overnight at home. So for people who are parking on street, this is the easiest way how to, and also the most economic way to build electric car chargers. Together with charging capability, of course, we need to provide a way to collect payments for the energy, because yes, it is fancy to provide energy for free, but this is not sustainable in the long run. And I myself am driving an electric car, but I am not a fan of free charging, because I strongly believe in solutions that are sustainable. So how it works? It works so that when you are connecting to the public charger, you are scanning a QR code with your app, or you are using RFID cards to authenticate yourself, and your car gets charged. After finishing the charging, your credit card is charged €1, €2, or whatever is the cost of the energy that you have used. Who pays for the energy? Well, city does, because you are taking the energy from the lines from the lighting. So whoever pays for the energy for the lighting is actually also paying to the energy distribution company for the energy that you have put into your car. Of course, they will get also a report and a chargeback, so that they recover all the cost for energy that has been distributed to the cars. So there is no need to worry that that people with electric cars would get all the fuel completely for free. They need to pay for the bills. By the way, we are using the same technology also for smart buildings, because if you are managing a building, an office building, or a shopping site, it is nowadays quite common that there are 1 or 2 charging stations already available. And when you are building 1 or 2 charging stations, you don't really need to have any special load management, because the cost is so low compared to the consumption of the building that nobody really cares really to solve this. However, if you are going to build 10 or 100 charging places on your parking lot, you need to worry about 2 things. First is your maximum reserved capacity for your grid, so that you don't risk problems with the distribution companies, or fines, or excessive cost just for the capacity. And also, it makes sense to set off the consumption of the cars of the employees or the shoppers with really green energy. So the system that we are providing is allowing to dynamically balance the charging speed of the cars based on different parameters. So you could have the visitors, you could allow them free charging for certain power and for limiting it for certain hours. Or you may provide for your employees free charging, but only from solar power panels. So we calculate what is the actual output of photovoltaic, which is on the roof of the building, and we are making sure that we are distributing only the solar power to selected cars. Or if you have a VIP like the executive director and he's in a hurry, he simply requires to get full 22 kilowatt charging speed in his car, so he gets 22 kilowatts no matter what. And all of this can be dynamically controlled with the same system. When talking about the smart lighting, yes, lighting poles are always installed in the places where people live, and where people live is a great spot to install additional sensors. For example, pollution sensors or weather sensors or noise or million other types of sensors, and with the power line communication that we already use to control the lighting intensity and charges, we are also providing this communication to the sensor so that we can populate the big data databases that Yukta talked about in the previous session. It's not exactly new concept. We are providing this on many places, mostly in Europe, but not only in Europe. And we are keen to look for partners also in other countries to provide this green and exciting technology for the cities around the globe. The largest implementation so far at the moment is Kiev, where we are already controlling over 50,000 luminaires and are saving millions of euros on energy. Or about almost 30 municipalities in Israel, which is using this technology. In Israel specifically because of the safety, because public lighting is critical infrastructure, and cable is much more resilient to hacker attacks than any radio solution. Okay, so I hoped I gave you a little bit of inspiration and maybe a little question. If you at all are aware how much are you paying for lighting in your city, and maybe if this bill can get lower. And I'm looking forward to your questions.
No, cool. Well, Milan, of course, is asking a question. He says super solution from SEAK, connection of lamps to a fully independent and existing power line network seems to be pretty wise and cost saving. Does SEAK use this network as an IoT network provider for others?
Yes, that's what I mentioned. We are also providing modules that allow a transparent data connectivity throughout the power grid network. Of course, the bandwidth is limited, but that's what IoT is about.
Yeah, cool. So, and then
So
maybe
no YouTube over power line.
And then I have also some questions. It's great that the smart lighting saves energy, of course. But does such investment have actually return for the city?
Yes, it does. In most cases, it does. The fact is that out of all the smart city technologies, smart lighting is one of the few that have a real return for the city. It does not make sense to save energy for small lights like below 50 watt bulb. It does not really make sense economically because if you are saving 40% out of 50 watts, you are saving like 20 watts, and it is not enough. It does not generate you enough saving to cover to have a fast return on investment. But in the cities, most of the lighting is 100 watt and more, and the typical return on investment that the cities are receiving from changing the lighting into smart lighting is 3 to 5 years.
Okay. Does this also answer the question where it makes sense and where it doesn't make sense?
Basically, yes. The stronger the light is, the better saving you get for the buck. And also what I have seen on many places is that when the municipality is thinking of providing smart lighting solution, sometimes the idea is that let's make a big communication network out of it, and let's put Wi-Fi hotspot, and let's put cameras and all of that into one big wireless network. And of course, this is possible. However, typically this is not cost effective. So in my experience, it makes sense when thinking about these solutions to run a simple Excel sheet and to calculate what exactly makes sense for the city, because it is not so smart to implement technology just for the sake of technology. We have to have a look at the real needs of the city.
Yeah. So, how do cities now approach you guys? Because I think, well, the smart city team is pretty huge right now. What kind of questions do you get from cities?
In the cities, the typical question is, or the typical question is, how fast can this be delivered? Or many times the problem is that the cities do not own the infrastructure, because this is this is maintained and sometimes even owned by a municipal corporation, or sometimes even private corporation, and the legal connections between all these entities are sometimes a little bit more complicated. So typically, from the idea to provide something like this till the system is really deployed, including all the public procurement and all these necessary things so that everything is transparent, it takes 1 to 2 years normally.
Wow. Yeah. Unbelievable.
Well, if the city is big enough, you are anyway not able to change all the lighting.
No, for sure.
Overnight. Okay,
No.
but the main point is that if you do this in stages, you are able to take the money that you save from the first stage and to use it to build the next stage, and to gradually build this with not so much capital. And honestly, as the solution is green, because the energy that you don't waste is the greenest possible.
Yeah.
Then it is also possible to get very good financing options from EIB and other banking institutions for this.
Yeah, well, cool. Well, thank you very much. If we can ever help you to connect you to cities via our ecosystem, we will be ready to do so. But we get here one more question from Will. How has been the experience of having to build the grid in Asia compared to Europe?
Horrible.
Can you explain why is it horrible? Is Europe horrible if it's Asia horrible?
Asia is horrible, but honestly, it depends country to country. When I said horrible, specifically the worst quality of grid that we have seen was in India. And it's simply because of the state of the infrastructure. So just to give you an idea, normally we have 230 volt in our grid, plus minus several percent. We have seen cities in India where to have 150 or 300 volt in your socket happens even several times a day. It's normal. It's pretty normal, but we took this as a challenge, and we actually learned a lot from these installations, and we made our products much more robust, so that we are able to survive this even these conditions. So I am pretty sure that if our solution can work okay in India or in Vietnam in the weather and in stable grid conditions, then we are in a very convenient position in Europe.
Yeah. If you can make it there, you can make it anywhere.
I hope so.
Well, sounds great. Well, thank you for being with us. Thank you, Milan, for introducing us to SEAK Energetics. So thank you very much. Have a great day there, and hope to see you soon.
Thank you. Thank you. Bye.
Bye-bye.